How many pennies do you think I can fit in this jar of water, which is filled to the brim, before it overflows? Oh, as you can see, it started to overflow. 37! That many pennies in a jar that was filled to the very top with water. Now, let's take a look at some extra footage I took at penny number 27.
Do you see how the water level comes over the brim of the jar? Magic? No. Science? Yes.
It's story time. Once upon a time, my 7th grade science teacher showed the class a flask of water. He filled it higher than the brim of the flask, and the entire class was in awe. Then he floated a paperclip atop it, and I think someone almost passed out. Okay, story time over. This is called surface tension. Surface tension happens because of the special tendency of water molecules to stick together.
Ever heard of water being referred to as H2O? That name represents the elements that piece together the substance that you know as water. Water looks like this. The two atoms on either side of the one in the center are hydrogen atoms, which represent the H2 part of the molecule. Two hydrogens, H2. The one in the center is an oxygen atom. Two hydrogens, one oxygen, H2O.
So, why exactly does surface tension happen? Surface tension happens because of a process called hydrogen bonding. Ever heard of the phrase opposites attract? It's true!
The hydrogens on either side of the water molecule are positively charged atoms, and the oxygens in the center of the molecule are negatively charged. This makes the hydrogens stick to the oxygens of other water molecules, forming a strong bond between them.
When water molecules touch the air at the surface, it makes the bond even stronger. When I put pressure on the balloon by blowing air into it, it becomes bigger, which then increases the surface area. The same thing happens to the membrane at the surface of the water. Because it stretches out so much, it increases in area, making more room for more and more water molecules to come up. So what happens when it can't stretch anymore? Well, not exactly, but something along those lines. Let's go back to the pennies in the jar of water experiment. The more water molecules come up to the surface, the higher the water level gets.
You may be wondering at this point, why isn't the same reaction formed in the water below the surface?
The answer is net force.
Something called net force if you add up all of the forces which act upon a given object.
The surface is completely balanced because all the water molecules cancel each other out. The net force is balanced. However, water at the surface is exposed to air, and the net force up there is unbalanced. The water molecules at the surface need more water molecules to stick to, and they pull together even tighter. Let's take a closer look at this.
Think of unbalanced force as an addition to a balanced equation. If we have a water molecule, H2O, equaling a water molecule, they are balanced. Now let's look at water at the surface. There's going to be a few unbalanced oxygens in there. Maybe even a carbon dioxide.
What? So why do we care about surface tension? Does it have a use? Well, put on your hiking sneakers, my friends, because we are going deep into the woods. Look very closely at this creature.
Ever seen one of these? It's a common water strider. Look how it runs along the surface, how the water makes dents beneath its feet. A water strider's foot-like structures are spread apart in order to maintain an even balance upon the water. The dents where the strider's legs meet the water are caused by surface tension.
There are a lot of hidden secrets in science just waiting to be discovered. I'm Izzy Cowan, future physical nanotechnician, signing off.